can watch this back with colleagues. Okay. Over to you, John.
Okay, guys. Thank you, Liam. I'm just going to share our screen. There you go. Over to John. Thank you.
Okay. We're going to talk today about our new process control range. And this is modern process control. The modern there refers to the fact that this is digital. Some of the process controllers out there work with small analog controllers. That's very nice in theory. It's very uncommon to find that in practice in industry. These days, everybody's gone digital, and so have we. So it's modern process control. There are 4 products in the range: flow, temperature, pressure, and level. And you can see the 4 models there. They've got a built-in controller, and they consist basically of some powder-coated metal housings with electronics built in, and then the apparatus on top. There are some rugged plastic handles so that they carry reasonably well. The dimensions of these are around ½ a meter by 40 centimeters tall. So they don't unfortunately fit into grapnels trays like everything else that we do, but they're not large and they're very easily portable. We've got a lot of learning objectives here, and you can see those listed there. There are some worksheets provided, and you are able to study the control function with these products, and we supply 3 sets of software with them, and you'll see that software later. If you want to do S-Plane and work with the S-Plane directly, then you're going to have to use MATLAB or something like MATLAB, LabVIEW, which is very good at doing sort of S-Plane to real world transfers. And the electronics block inside is compatible with doing that. So with these products, you can learn all about driving process control systems, about sensors and their calibration. You can learn about not just PID control systems, but also on-off, which is fine sometimes, and hysteresis. You can learn about the time constant of a system, about different types of controller. You can learn about control functions and block diagrams. We like programming here at Matrix, as you know, so you can learn about how to implement PPI and PID systems in pseudocode and very basic code. And the really interesting thing there is actually that the mathematics behind process control is horrendously complicated, but the implementation in software is actually incredibly simple. And so we like to demonstrate that. You can learn about some problems with process control systems like integral windup and the need for derivative filtering. You can learn about Ziegler-Nichols, which is a way of trying to quickly characterize process control systems. And it doesn't always work, of course. So you can also learn how to manually tune them as well. So there's quite a lot of learning objectives that come with the kit. There is a full API, which is Application Programming Interface. So you can use these products with any programming language you like. You can use it with any computer you like. You can use it with your mobile phone, your Raspberry Pi, whatever you want. And this is an increasing feature of Matrix products. We are seeing that it is now very difficult to predict exactly what customers want in terms of the computer and software that they want to use. And so this API is usable through USB, Bluetooth, and Wi-Fi and local area network. And there's basically a set of commands that you can call to control the system. So it can be controlled by anything. And that's a really great way of giving great flexibility for customers. So there's some details there you don't necessarily need to know, but you just need to know that whatever the customer wants in terms of software and hardware, the kit is compatible with it. I'm going to talk a little bit about the electronics because that's something I'm interested in. And what we've got in these process control rigs is a really high-tech electronics controller. As you know, we do a lot of work with electronics, with E-blocks and other products. and Matrix is really, really good at this. We are world experts in control, I like to think. So there's a small circuit board. You can communicate to it using USB, Bluetooth, Wi-Fi, or local area network. There's a powerful processor. It's got some inputs and some signal conditioning and a couple of motor drivers, and then a power supply. So the overall topology, if you like, is fairly straightforward, but the software is what makes it is really good. So the API is like a little mini operating system that comes with it, which does data logging and control. There's no external controller needed. Everything is provided in every rig. So there's no external sort of data acquisition systems needed. It's all done using Flowcode, and Flowcode now has 2 branches, Embedded and App Developer. So the software is created with App Developer, but the circuit board is created with Flowcode Embedded. And I've put a picture of the controller there because it's what we like. So you can see the integrated Wi-Fi system, the integrated Bluetooth, the integrated local area network. There's the processor, a couple of powerful motor drivers, and some sensors and signal conditioning. Oh. So let's talk about the individual ones and just highlight the individual parts on each system. Can we mute somebody? Okay. So this is a steel backplane, if you like, an L-shaped bracket with a back and a surface onto which all the parts are mounted. The controller is behind here. The connections for USB and local area network are on the front. We always give a small diagram here just showing the system, and the system diagrams are really relatively straightforward. There's one input and a couple of outputs. So one output controls the pump, another output controls the valve, and there's an input with a flow sensor. So here you can see the tank. It's just a small tank of water, probably holds about 7 or 8 liters of water. There's a pump at the bottom of this tube. So the pump pumps the water out. Here's the flow rate sensor. Then it goes into a rotameter, which is a mechanical flow rate sensor. And there is a valve here. For pressure, here you can see the block diagram. There is a pressure vessel, which is a plastic chamber. There is an air pump here. There is a small manifold, and there is an outlet here, which is just a pressure release valve. And there is also another release valve and a solenoid valve. So you can suddenly create a disturbance and you can regulate how much disturbance you want. And then there is a conventional pressure gauge here. All of these systems, we like the students to be able to calibrate the system. One of the jobs they've got to do is to calibrate the electrical sensor against the mechanical sensor, if you like. So that's pressure. Temperature is relatively straightforward. There's only there's a metal block inside a chamber. There is a fan at this end. The metal block has a big Watt resistor on, which just acts as a heater. And that's a relatively straightforward system. With level, we've got, again, a water tank with 7 or 8 liters of water in. There is a chamber here. There is a pipe. At the end of this pipe, there is a pressure sensor, and the pipe is open at the bottom. So as water flows into this system, the water level flows up the pipe, which creates a pressure inside this tube, and that pressure is proportional to the level of the water in the chamber. There is a pump here, which pumps water from the, there's a pump in the water container, pumps water up through this pipe into the vessel, and this is a valve, a solenoid valve, which opens the bottom of the chamber so water drains out. So you're able to really neatly have a system that measures or controls the level of a system. Now, so we've got these 4 systems, and there are 3 different pieces of software that are provided. All these bits of software run on a PC. They are made using Flowcode App Developer. And the first one is a manual piece of software. And basically the students, all of these systems have a drive, and the students are understanding that the drive is between 0 and 100%. And this is a pulse width modulated drive. And to start with, we are going to just drive the system at between 0 and 100%, and we're going to gauge later on how many liters per second or something that equates to. So there is always a drive, there is a load, and the load might be for pressure, for example. If the valve is open, there's a greater load, and if the valve is shut. So all process control systems have a load. It's a leakage, if you like. And then there is a graph. There's a graph on all the applications. And so here you can see that the students have controlled the rate of drive. The students can just interact with this user interface just by clicking on this little slider. So the slider is an input, and here you can see the pressure in this case, which is an output, again presented in the form of a slider. So the students here are understanding that a certain drive will produce a certain pressure. They can also calibrate the system here. There is a 0. These pressure systems and some of the other sensors require require some zeroing and calibration. So this first system, manual software, is just so the students can get to know the parameters of each process control system. The second bit of software is just on-off control. And there are the slower functioning systems, on-off control tends to work better with them. Some systems, it just is a complete disaster. So now the drive has a certain set point because it's been calibrated. So in this case, we can try and reach a certain PSI set point. Again, there is a load, so we can open and shut the valve. And here is the output pressure. And so you can see how the system functions with just simple on-off control. And you can see the need for PID control, of course, because on-off isn't perfect. And you can set the hysteresis value here. So you can see how the system will hunt to try and achieve a certain level. So that's the on-off control system. And then the third bit of software is a full PID control system. So in this full PID control system, again, you have a set point, you have an output, you can change the load on the system, and you can use the graph to monitor the system's performance. And on the side here, you can see that you can set all the scaling in this properties bar. You can set the values of KP, KI, and KD. You can set whether you want integral clamping on or off. You can set whether you want the derivative filter on or off, and you can set the derivative filter coefficient. There's some other controls here where you can dictate how the graph works. And if you want to, you can log all of the results to an Excel file or a CSV file so that you can analyze it in Excel or in whichever package you like. So those are the 3 different bits of software that are shipped with the system. And those bits of software are just downloadable from our website, and that's in place now. I've done a screen there that shows you just a close-up there of the properties bar. So you can set the control frequency as well. And one of the things we do is in the early worksheets, we get the students to understand that every system has a time constant, and they measure that time constant. From memory, I think that's the time constant of a system is the time required to achieve 66% of the output value. And then they can understand that the control frequency and the time constant are linked. And so they can set different control frequencies. Clearly, if you're doing something like flow, it's very fast responding, and you want to measure that many times a second, whereas temperature is very slow responding, and you want to do that several times a minute. And it makes a big difference to your performance, how quickly you take those measurements. So you can see there's the PID close-up. Okay, so we need to then look at the results you get from doing this. So here what we've done is for flow, I say flow is the fastest responding because water doesn't compress very well. It really changes very quickly. So you can see the effects of a simple on-off control algorithm here. And what we do is we get students to implement Ziegler-Nichols. Now, Ziegler-Nichols were a couple of engineers, I think in the 1930s, who came up with some rules of thumb as to how you choose the values of Kp and Ki and Kd, the proportional, the integral, and the derivative controls to control process control systems. And they're sort of wet finger estimates, if you like, as to how you get these numbers. And so we put that in the manuals, and Ziegler-Nichols has several different types of control algorithm as to whether you want a little bit of overshoot and a fast response, or no overshoot and a slow response. And the control systems that you have often want operating in different ways. So we get the students to implement Ziegler-Nichols, and you can see here, this is the PID Classic, which was used as a reference. So you can see here, the red trace is the output. There's a blue trace, which is the set point. So here the set point was at 150. We changed the set point to be 100. And here you can see how the system reacted. And you can see this is a pretty classic PID. There's minimal oscillation, or there is a tiny bit of oscillation here that you can just see. And so in this case, Ziegler-Nichols has been pretty spot on, and it's worked really well. Now, the other thing we put on the graphs, which is really neat, it's really difficult for students to understand the control equation and the effects of PI&D and how you manually tune systems. And so what we've got here is you can see the proportional factor. So the set point and output on the left-hand side, but the control value contributions on the right-hand side. So here you can see the proportional output. That's the purple trace. The derivative output is the blue trace. And you can see that the derivative is always noisy. It creates lots of problems in process control. And you can see here, the yellow one is the integral. Right, so you can just see there's a yellow one in the background there. That's the integral contribution. So we've got three contributions to the equation. P in purple, in blue it is the differential, and in yellow it's the integral. And in the properties, you can turn all of these on and off. But actually, this has been brilliant in terms of explaining how PI&D work, and in getting students to understand the contributions to the control equation, and in teaching them how to do manual tuning of PID systems. So the flow one in Ziegler-Nichols works really well. Here you can see we've put the derivative filter on. So in blue, you should see that the noise is less. Now, I don't know why we've got more oscillation there. It must be a different setting. But you can see that the change here was the set point went from 200 to 100, I think. And so you can see the output was noisy for a while before it settled down. And here you can see another algorithm with Ziegler-Nichols. One of the parameters you can set where there's no overshoot. So let's say you're delivering drugs, for example. You've got one of these systems where it's delivering a certain amount of drug intravenously. You don't want any overshoot in terms of the flow rate in a drug delivery system. So here you'd use a no overshoot algorithm or something like that. So you can see here, there's hardly any overshoot. You can see that's the integral. The green one is the overall contribution of PI&D. The yellow one is the integral. So you can see how that changes. And so you can see what's happening in your system. And I've zoomed in here. So actually the times there are quite small. Okay. Here's a result for pressure. Here you can see the hunting effects of the motor and the motor coming on and off. The hysteresis level there is the green trace. So you can see how for a given hysteresis, you're going to get a given frequency of output there. And again, for pressure, you can see this is the Ziegler-Nichols. Ziegler-Nichols settings for PID Classic. Not quite as good as the flow, but you can still see you've got some overshoot and then it settles down. And you can see again the contributions of PI and D. And this is going to be quite repetitive now because we're basically just implementing the same thing for different systems. So again, you can see integral clamping was a big thing on the pressure one. So there was a need for integral clamping there. No overshoot, that's an interesting one because it hasn't quite worked on this system. Ziegler-Nichols does not always work. And hence the need for manual tuning here because we have got some overshoot. And so you can see the results that you're getting for all of the different systems. Now we've got a document for you that gives you this information because the thing that your customers are going to want is they're going to say to you, okay, either show me it working, and of course that's a little tricky, or show me the results. So just as we did for electrical machines, we've now got a nice document that shows all the results for all of the models that we've got with this software. Temperature is the hardest one to work with, I found, because the time constant is so long. So it can take 10 minutes for an adjustment to take effect properly. Pressure's the nicest. It responds well, and it's probably the easiest to use, the most well-behaved, if you like. Temperature just takes a long time. So, you know, you can be sitting an hour to get the results you want. Okay. We haven't done anything on the curriculum on here. Let's just see. Ah, you're going to go into that. Okay.
Hi guys.
Are there any questions there, first of all?
Yeah, do you want to ask questions of John first before I go into how we can help with marketing? Any technical questions, guys? Please feel free to unmute yourself or even put it in the chat.
Have I gone on too long now?
I thought it was brilliant.
Did you?
We've got some questions in the chat.
You can keep your job for another week.
Any questions? Give me a second, guys. I've been made aware that it was not allowing people to unmute themselves. I've now made it so that people can unmute themselves. Sorry, that was a technical issue. So if you did have a question but you couldn't unmute yourself, you can now unmute yourself. If anybody has a question, perhaps, of John on technical. Okay, I'll start with the marketing and how we can help with marketing. But as usual, if you do have any questions, please just unmute yourself. And also you can put it in the chat and one of us will answer the question. So first of all, as with all the Matrix products, there is plenty of marketing support out there for you. One of the main ways is through the dealer portal. I hope that most of you know how to use the dealer portal. It's on our website. It's www.matrixtsl.com/dealers/login. And you should all, every one of our dealers should have a username and password. And once you click on that and log in, there is quite a lot there for you. Give me a second, I'm just going to log in.
爸爸，你的声音可以那个放进去吗？肉眼看见，强度却极大，锋利无比，能将大部分金属轻易切成碎片。
Typical screen on the dealer portal, guys. So you've got two areas for flow code 9 and flow code 8. That's more about flow code. I'm going to focus on the process control. So the specification documents for any tenders that you might be writing are available in the spec documents there. In the marketing files, it will bring you up to this page. Now, obviously, you've got things about us, various documents, but at the bottom, you've got this process control marketing zip file. I think there's about 5 or 6 documents in there. Let me just open that up. And within there, you've got things like images. There is a process control catalog. You've got the results that John was talking about that customers may well want to see before they make a purchase. And you've got also this presentation that we're doing now. So you know there is plenty of help out there for you guys. Just waiting for that to download. It's going to be another couple of seconds, and I'll just show you exactly what's in that zip file. So you can see you've got, these are the curriculums, I think, for each. Oh no, they're the images, sorry.
There's one curriculum for all.
So it's one curriculum for all, and that will be in the supporting documents. At the top there's the curriculum. This is references. What's that, John?
Yeah, when you there's 2 documents, the curriculum and the reference is a kind of how to set things up, how to set the software up and all that kind of thing.
Cool. This is this process control presentation here. That's the presentation that we're doing as we speak. That's the results, and then you've got the process control spec, which is the you know, the information that you can put into tenders to help you with those. So let me just go back to the presentation. Okay, so that's the dealer login. This is an example of the technical specification that will help you with tenders. You know, some keywords and system overviews and things like that that will help you if you're being asked by a customer to help write a tender. This is the curriculum that John's told us about. It's all in one, so whether it's flow, level, temperature or pressure, it's all in one curriculum. Any more pointers on the curriculum, John?
No, it's fine. It's downloadable. You can have a look at it today. It's on the website now.
Cool. It's a PDF, so you can print that out for your customers. You can send it via email. You can kind of do anything with it. I've been through that, so it's just basically telling you a bit more what's on the portal. So we've actually got a specific brochure for process control, which is quite nice. That again is on the dealer portal. And we've also released, I think last week, a new marketing video for process control, which is quite nice. It introduces the range. Some people, they don't want to be reading lots and lots. So an alternative is you could send them a video. I'll quickly just click on that to show you. It's on our new YouTube page. If you haven't already subscribed, it'd be great if you could. So yeah, that's on our website, on our YouTube, Matrix Technology Solutions Limited. Just type in process control. It should be one of the first videos on our YouTube, but yeah, send that to your customers. It's a really great video. Okay, so next up, we have got prices. As you can see, it's a very, very a reasonable price. The flow control, we have a version for UK, EU and US. That's just about the plug adapters that come with the kit. We have a dealer price of that for $1,950. I'm pretty sure that you'll be pretty happy with the price there, guys. The temperature process control system is $1,125 for dealer price. Pressure control, pressure process control, should I say, is £1,387.50. And the level process control is £1,875. We're confident that that is probably the best price on the market. And it's all live in your price list that you should have received in January, the updated price lists. So, you know, that's kind of where you'll find it. And, you know, we're really, really confident that the price point is excellent. Okay. Now, guys, I think it is time for questions. There must be some questions out there, guys. There's quite a lot of you. For me or John or Liam, any questions at all?
Can you, this is Eric from Norway. Could you say anything about the competitors? How this compares?
Hi, Eric. How are you? You okay?
Doing fine, thank you.
Good. John, Liam, could you help here? I'm not too sure about
this. There's quite a few people who have something that looks very similar. I think we score in several ways. First of all, this is a digital system, not analog. Now, that's a shame in one sense, because analog systems are an awful lot better behaved from the mathematical point of view. So they're probably slightly harder for students to work with in some ways. But again, our philosophy is this is real. This is what they're going to come across. So, you know, that's what they've got. So Summer Digital, I think you'll guarantee pretty much that we are 2/3, if not less, than the cost of anybody else's system. Other people will have a separate data logger control unit. Ours is totally integrated because it's just how we do things. We have looked at other systems and learnt from them, I hope, and I would hope that we've produced something which is better. I think we are very aware that use with MATLAB and LabVIEW is big. We've got our own software, as you've seen, which is for discovering PID, but we're very compatible with third-party systems. I think the other thing that we focus on quite a lot is different levels of student. So process control is a strange subject because technicians want to implement it and they don't want all the maths. They might want to understand the control function in KP, KI, and KD, but they don't want to solve transfer functions in the S-plane, which is a sort of engineering undergraduate task. So we've got two markets with this. We've got the technician market, installers, if you like, and we've also got the second or third year engineering students as well. So the software we've provided is clearly for technicians and for beginners. The S-plane stuff has to be done by MATLAB. So you've got two markets for this. So we've looked a lot at what other people do. We've come up with something which we think is better. We've come up with something which we think is different, and we've come up with something which is certainly cheaper.
Okay, thank you.
I just had a couple of other points to that, John, as well, which you might have touched on in your presentation. My internet dropped off halfway through, but I'm sure that you talked about the portability of the equipment. I noticed that there's a question in the chat, Alistair, just from someone asking if they can just see one of the units. Do you have one there that you can just hold up just to give an idea of size? Of course, other competitors in this market do have portable systems as well. That is certainly the case. But it is another good selling point to our system. That's the pressure unit that Alistair has there. They have carry handles on the side, so they're very easy to take around the classroom and the lab and move from lab to lab, etc. The other point that I'll make as well is, John, did you mention anything about the remote capabilities of the system?
No, I didn't.
Okay, so the system, yeah, you can go on then. Go ahead. Go on.
Now these systems are all compatible with Bluetooth, USB, and Wi-Fi or local area network. This is a general move for all of our equipment. Everything is going to come with all of those interfaces. Now, one of the benefits of this is that you can set up students to use this at home, right? So one of the problems you've got, of course, is you've got, say, 70 engineering students and you've got 10 bits of kit. And so you have to let them use it either in groups where they often cannot learn that much, or you've got to use the equipment different times. Now with this kit, you can use it over the internet. So now we've done this between two towns here in Yorkshire, and it's been fine. And it works well. It works better with some bits of the equipment than others. Temperature again goes on forever, so that's not great. The fluids one is so quick that you need to be next to it sometimes. So that's not great over the internet because there's always a bit of lag over the internet. But the pressure and flow ones work really well. So if there's anybody out there who fancies controlling one of these systems from wherever you are and helping us take that to the next level and make sure it works between countries or across the world, then that would be great. We can set up the software with you. You've got to enter your IP address and do a couple of other things. And if everybody fancies doing that, then that's great. That would be great. And one of the potentials there is you could actually do that with your customers. Although the IP address and firewall things can take a bit of navigating through, so it's not necessarily instant. But if there's anybody out there who fancies helping us do this over the internet with, say, our Precious system, then that would be brilliant.
Thanks, John. So yeah, I mean, that remote learning capability is certainly at the moment quite a hot topic in education, and I'm sure will be moving forward as well. So I just thought it'd be worth us mentioning that. Another question that's just come in is whether the unit comes assembled already or whether the students build it or part build it. All units are more or less built ready to use out the box. I think that there is just maybe one or two units which for shipping purposes, there's a one part that needs to be attached when it arrives with the customer. And I think that is probably the one that John's got now, which is the level unit. John?
When this one arrives, this piece is detached and you have to add it to it. And I think there's 4 Allen key bolts that you've got to attach. Clearly it's just very tall, so we take this off, but everything else is assembled.
So hopefully that answers that question for you.
Any more questions, guys? I haven't checked the chat actually.
What about some feedback from them? What do our partners think?
Yeah, John's welcoming any thoughts, guys? Hello?
That's a very bad signal, I think. Who was that talking? Nidal. Is that Nidal?
Yes.
Hi, Nidal. How are you? Nidal, we can't really hear you. You're just coming across as a few crackles.
Could you, Nidal, could you put your question in the chat? We can't really hear you.
There's one more question just come into the chat. Whilst Nidal types his, Alistair, do you want to just address that other question there about control, PC and manual?
Shall I do that?
Yes.
You have to have a PC to control this if you want to use our software. So there are no controls on the unit as such. It has to be done from a computer, or you could do it from a computer other than a Windows PC, but you'd need to write a little something and interface to the API. But pretty much, really, most people are going to have a Windows computer to use it. Nadal is down there. That looks like Nadal.
I think Nadal's just typing his question now, so we should have something from him.
Any more feedback, guys, or questions? We'd love to hear
Use with
your
a
opinion.
tablet. John, use with a tablet. From Eric.
Certainly doable. We haven't done software for a tablet, but so if you want to do that, somebody could write it. If there is a demand for that, well, we could write that as well. Depends what people want. It's too early to say at the moment.
And the software that we develop the applications using, we're looking to move that to tablet compatibility potentially in the future as well, John, right?
Maybe. Now, again, a tablet is a funny thing because you can get a Windows tablet. So if you've got a Windows tablet, you're fine. Now, if you've got an Android tablet or an Apple tablet, well, you're not fine. And there are things like, is it ThingSpeak? Is that the right word? No.
Yeah.
What's that? App Inventor. So if you've got App Inventor, you could create something, but it would be a non-trivial job, really. So it's not one we want to take on lightly. So is that from Nidal, that question about 4 processes?
No, this
once?
is a separate question. This may be from Nidal. Yes, I think it is. Yes.
Yeah, at the moment, Nidal, we are just focused on this, where we've got just one system on each thing. A few of our competitors do the 4-in-1. Let me ask you, Nidal, what's the ratio of sales between the 4-in-1 system sales to the individuals? Any other questions whilst we're waiting? We're anticipating that there are some parts of the world where this is going to sell more than others. So the oil industry is, of course, awash with process control. So the Middle East and Norway, Eric, we've got you down for 20 of each kit every year. Is that all right?
This is higher.
It's not. I shouldn't be a problem for a salesman like you. Okay, from Nidal, you're right. In practice, you've got more than one. More than one process control system. You've got temperature and pressure, for example, or level and temperature. We can do that. It's been interesting when we've researched it. For us, it's about the ratio of sales. A 4-in-1 system is expensive, and you probably can only get, say, 2 students on it at once. Whereas having the individual process control systems, it's going to be much cheaper. So the pounds per student through process control, if you like, that's a much better equation. We also really like the simplicity of this. Process control is not easy, and doing more than one quantity at once, I can imagine is harder, but I've never done it. So again, for me, it comes back to what is the sales potential of the 4-in-1 system. If you feel it's something that's got a huge potential and you're going to sell a lot of them, then we'll think about it. But my sort of thoughts at the moment are that the majority of sales is going to be the individual systems. I'd love some more feedback on that from you. Okay, how to drain the water from the sump tank. We have thought of that, which is lovely. There is a little hole at the bottom of each tank. Now, can you see there's a little black hole? Put your finger towards it, Al. There's a little black hole there.
Yeah.
That little black thing, and that's how the water comes out. You just shove a little pipe in there, an 8mm pipe, and that's how you drain it. Now we anticipate that a department might be doing process control, say in the summer term, and they'd have a number of these things, and they'd fill them with fluid, and they'd stay filled for a few weeks, and then they'd empty them at the end of that session. We also ship a little bit of barley water with the systems, and this barley water stops the water from going green and having algae in it. So it's we sell a little, or we give you a little vial of barley water there. I'm glad we've thought of that one though. Somanath, good question. Is there anything else we should have thought of? From Joshua, is it possible to cascade all process control trainers? That's a good one, Joshua, and no, it isn't. But that's an interesting one. Again, you'd end up with a 4-in-1 trainer, and I'll have to think about that. Yes, all 4 systems are ready for selling. We're taking orders today. We've got about 20 sets here ready to be assembled. So don't let anything stop you. From Somanath, the pump is submerged in the tank. It's a tiny pump. Maybe I can show you here. If I lift that up, can you see that? There's a little thing with a wire there. The pump is inside the tank in there. Yeah.
There was just a question about delivery times that came in as well, and delivery time typically would be 2 to 4 weeks on this equipment. It is an assembly job for us. We have all the parts ready, as John mentioned, for 20 sets already in stock. We've already shipped the first units, and I think they're in a UK institution being utilised since just before Christmas, which is nice. There was a question also that came in from Jay in the Philippines, I think, and he's asked about the software platform, just again asking that, the main software platform that we've shown today is the proprietary software that's developed by us and our own engineers, and that's used for this particular set of equipment. But this equipment and the curriculum also allow us to software including MATLAB and LabVIEW. And so these sets are also compatible with those software platforms too. Okay. Good. I think, Alistair, you'll probably later today or tomorrow send round just this presentation and price list to everyone, and the recording as well. Yeah.
Yeah, no problem. If anybody does have any questions in the meantime, you all have my email address and phone number. If you want to give me a ring, that's no problem. Thank you all for attending. It's been good. I hope you're as excited about process control as we are. And yeah, we hope you've got all the tools you need.
Thanks to everyone for joining us, and thanks, John. Thanks, Alistair.
Cheers, guys.
We'll wrap it up there. Cheers.
Take care.
Thanks. Bye-bye.
Thank you.
Bye-bye.
Bye.